In today's video, let's first start with a common approach in algorithm design for finding the minimum and the maximum values in a list. So to finding the both minimum and maximum values of an array with n elements, we can do so by using 2n minus 2 comparisons by finding each value independently. So this involves by using n minus 1 comparison to find the minimum and also n minus 1 comparisons to find the maximum. Suppose we have the array of numbers 3, 1, 4, 1, 5, 9, 2, 6, and we try to find the minimum and the maximum by using this naive approach. So first we try to find the minimum value, so we just compare the first two elements, 3 and 1, and we take the smaller one, which is 1, and then we compare 1 with the next element, 4, and we keep 1 as it is smaller. So we continue this process with the remaining elements, which is always carrying forward the smallest we can find so far. And after 7 comparisons, because this array has 8 elements, right? So we can determine the minimum is 1. And then let's talk about finding the maximum. So we just compare the first two elements, 3 and 1, and we take the larger one, which is 3, and we compare 3 with the next element, 4, and we update the largest to 4. So we just continue this process with each next element, and we always updating if the current element is larger. So after 7 comparison, the maximum is determined to be 9. So this approach is uses a total of 2 times n minus 1 comparison for an element list. So for this array given, this could be 2 times 7, which is equals 14 comparisons. However, there is a more efficient method that uses fewer comparison by pairing elements and comparing them to each other to separate potential minimum from maximum, which will reduce the total number of comparisons we needed. So this is very useful in some scenario where the comparison are costly or need to be minimized. So let's try to explore this more efficient method. Let me try to explain this more efficient method by reducing the number of comparisons needed. So for finding the minimum and the maximum value in a list, instead of comparing each element to the current minimum and the maximum value independently, this method processes the elements in pairs and makes 3 comparisons for each pairs. So this technique reduces the total number of comparisons to about 3 times the floor of n over 2, which is more efficient, especially as the size of the list increases. So let me demonstrate this method step by step. First, we pair the elements we get 3, 1, 4, 1, 5, 9, and 2, 6, and then we initialize the comparisons. We compare within each pairs to find the local minimum and the local maximum. So the first pair, we compare 3 and 1. So the smaller one is 1, which is our local minimum, and the larger one is 3, which is our local maximum. And for the second pair, we compare 4 and 1. The smaller one is 1, which is our local minimum. The larger one is 4, which is our local maximum. And for the third pair, we compare 5 and 9. The smaller one is 5, which is our local minimum, and the larger one is 9, which is our local maximum. And for the last pair, we compare 2 and 6. The smaller one is 2, which is our local minimum, and the larger one is 6, which is our local maximum. For finding the global minimum, we compare the local minimums from the pairs, which is 1 from the first pair compared with 1 from the second pair, and then we keep 1. And then we compare the result with 5 from the third pair, we still keep 1. And then we compare the result with 2 from the fourth pair, and we still keep 1. And for finding the global maximum, we compare the local maximums from the pairs, which is 3 from the first pair, we compare with 4 from the second pair, we keep 4. And we compare the result with 9 from the third pair, we still keep 9. And then we compare the result with 6 from the fourth pair, we still keep 9. The final minimum is 1, and the final maximum is 9. So instead of making 14 comparisons last time, which is 7 comparisons for minimum and 7 comparisons for maximum, this time our method makes 12 comparisons only, which is 2 comparisons per pairs times 4 pairs, which equals 8 comparisons within the pairs. And we have 2 comparisons for finding the global minimum and 2 comparisons for finding the global maximum, which equals 4 comparisons among the pair results. So this approach is particularly beneficial for large data set, where reducing the numbers of operations which lead a significant performance improvement.